Hey guys, sorry I can't work out more time to spend with you virtually due to the in-class things that are going on here. So I wanted to take this time here to kind of show you a little bit about the properties of shapes worksheet that you're going to be working on. First of all, let me point out in your project Lead the Way lesson under the course landing, you have a general student resources page. In there, you have a link to the engineering formula sheet. And if you click on that, it actually gives you this link to this 11-page document that has all the formulas, or probably 90% of the formulas you'll use in engineering class. The main one you're going to be focused on for this activity is Table 3, which is plane geometry, which gives you all the area and circumference and perimeter formulas that you'll need for various polygons and shapes that you're going to be in this activity. So this is going to be essential that you refer to this formula sheet as you do these. So let me share with you the bug here and show you, sort of guide you real quickly on how this works. One thing you want to make sure is you pay attention to the grid spacing. The grid spacing changes depending on the problem. In this case, it's equal to 1 inch. So if you count 8 squares across here, you get 8 inches. 8 squares here, you get 8 inches. Then obviously the area of a rectangle is, I think they call it like A times B. We used to do base times height or side squared, right? So you can then figure out your area by simply plugging those two numbers in. When you get to the second one here, it says you're going to revise this area. So instead of this area now being 64, it's now going to be 90.25. And you're going to plug that into the area formula and the side squared and use the square root to go figure out, well, what would be the side of the square if you increase the area to 90.25. And then using that new length, if you've got 8 grids or 8 squares down through here and that new length on the side, what would each square represent? So they're sort of asking you these questions in a out of the box type of order, where you got to think more. It's more than just going and finding the area. You got to think about some things and what you're using the formulas to solve a problem, right? Like this one says, you want a rectangle that has at least an area of 2.25. Notice now the grid has changed to 0.25, so each one represents a quarter of an inch. So if you count the number of squares up through here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you do 9 times 0.25, you'll realize that this length is 2.25 inches. And what they're saying is, how wide would this rectangle have to be? We don't know. How wide would this rectangle have to be in order to produce an area, which is base times height? If your area, you already know your area is 2.25, you already know your height is 2.25. So you would plug all of this in the formula and then you would solve for B. I think it's pretty obvious what B would be. And then once you figure out B, you use this 0.25 per inch, 0.25 inch square, and figure out how many squares you need to draw over in order to make that rectangle have 2.25 square inches. This one here is like a what we call a rhomboid, which is actually just another name for a parallelogram. And so since it's like a rectangle, it has the same formula as a rectangle. Area equals base times height. The base down here, there's 3 squares, and again, they've gone back to 1 inch. So this is 3 inches. And remember, when you do the height of a parallelogram, you don't do the slanted side. You actually come on over here and you do the perpendicular height. So you'll need to count the squares there to see what your perpendicular height is, and that'll be able to give you the area. Number 5 is pretty well given to you. It says complete this obtuse angle to make an obtuse triangle. So pretty much you're just going to connect the line here. You're going to check it though to make sure it's accurate. Again, you can check your grid units. You can determine a length, a base across the bottom, and then you want to determine the height here again. So you get your base, you get your height. Make sure this has an area of 1.75. So this sort of continues along the same vein. Let me urge you, since I'm not able to spend as much time with you personally on the virtual chat because of the interaction here in class, please ask questions, drop me a message, request a live meet after school sometime, and we'll get together. If you have any questions on these, you can ask specific questions about all of these. Again, pay attention to the grid, and then pay attention to your formula sheet, which has all the formulas on it. And hopefully through that, you should be able to figure out how to solve these problems to some degree of accuracy.